Hello everyone, welcome to Exampur. Today we'll be starting with the chemistry part. So yes, who all are present here, kindly give me your attendance so that I can start conversation with you, and we'll be discussing all the important questions which were asked previously in the SSC examinations, whether it is CHSL, Steno. We are discussing about several SSC examinations. Fine. So yes, today we are starting with the chemistry part, and after finishing the chemistry, then we'll be starting revision with the bio, physics and chemistry. That is, we'll be having mixed question then. So yes, let's start with this chemistry part. So let's have the first question. What's the first question of the day? The first question is, who proposed modern periodic table? Now this is from CHSL 2016. We have four options. What are they? First one is Faraday. That is, we are talking about Michael Faraday. Then Mendeleev, Newton or Bohr. Full name Niels Bohr. So yeah, who was the one who has actually proposed the modern periodic table? Now see, when we talk about modern periodic table, that means we are talking about the periodic table which is existing in the present time, right? We know that there are several elements in which we talk about metals, non-metals, metalloids. Like if I talk about sodium, calcium and all those particular things, so these are present in the periodic table, right? These are the elements. Now how many elements are there, what are rows, periods, I'll be telling everything. But before that, this answer, so we have Madhana's answer, and Madhana has given answer B, and that's true, Madhana, the correct answer is B, that is Mendeleev. But there's a confusion between the candidates, sir, whether Moseley would be the correct answer or Mendeleev. So let me tell you, Mendeleev was the one who gave this concept of periodic table, right? The present periodic table. I'm not talking about Daubernier stride or those particular Newland's octave rule and all, but present periodic table which you are seeing was actually originated in the mind of Mendeleev. But at that time when he gave this concept, there were several errors, there were several issues which were actually resolved by Moseley. So Moseley is the one who has actually given the present periodic table, but the idea which came into the mind or the starting was actually done by Mendeleev. So I guess this point is clear. Do not get confused with Mendeleev and Moseley. It's very important. Mendeleev was the one who has given this logic, but there were several issues which were resolved by Moseley, and Moseley has given the periodic table which presently exists. So which one is it? Let's have a look. So here Mendeleev is the correct answer. Awesome. Udbhav, Madhana, totally correct. Now what's that periodic table? It's this one. This periodic table, exact this one, is actually given by Moseley. Now one more thing, prior to Moseley, everyone who came, they all were talking about atomic masses. What? The periodic table that was actually made was made according to atomic masses. But if I talk about this present periodic table, this is according to the atomic number. Fine. So please do not get confused with this part. Now there are several questions which are asked from periodic table. If I talk about this part, that is, just have a look. These rows, just have a look. How many are they? 1, 2, 3, 4, 5, 6, 7. These rows are actually known as periods. What are they? They are known as periods, and it is asked in the examination. How many periods are there? So here we can say that there are 7 periods. In the similar manner, if I'll go with this columns, so these are total 18. So if someone asks me about the groups, there are 18 groups. Very important, please do not forget. How many groups are there? There are 18 groups. How many periods are there? There are 7 periods. Now, if you are able to understand this periodic table, then you can solve any type of question. That is, whatever question is asked in the examination from the chemistry, most of the questions will get solved if you are able to understand this periodic table. So what's in that? We will be having other questions as well. So we'll be discussing that. But this periodic table is in accordance with the atomic number. That is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. What's that? This is the sequence order. See, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon and so on. And if you remember about the starting 20 elements, it would be easier for making whole periodic table. How this is possible, we'll be understanding this one by one. Okay, so these things are clear till now. Let's move forward with the next question. Next question is, the modern periodic table consists of 18 groups and 7 periods. We have discussed it, right? What is the atomic number of the element placed in the second group and 4th period? So this is from CGL 2016. Can you answer this? Madhana, Udbhav and all the other candidates who are there in the session, kindly like it and share it. And yes, please give me this answer. My question is, we have understood what? Modern periodic table. We were discussing about Moseley over there. The concept which originated was the person who was there, that was Mendeleev. And the present periodic table which we are using, that is the modern periodic table, that consists of 18 groups and 7 periods. Remember? Now my question is, if I talk about the second group and fourth period, so what is that particular element? So can you give me this answer? Once you give me this answer, I'll explain this part as well using the periodic table. But first answer please. Till then I'm making the periodic table. So there were 7 periods, right? 1, 2, 3, 4, 5, 6, 7. And there were 18 groups, right? Till 18. If I talk about 18, here we have noble gases, that is helium, neon, argon, krypton, xenon, right? Radon. So here, if I'll go with this part, this is actually group number 18 where we are having noble gases. But we are asked about the fourth period, second period and fourth one. That is, we are leaving these 4 behind. So yes, this one. So which is this particular element? So I have a trick over here. Just have a look. If I'll make this periodic table for the first group, I have a trick, that is Halina ki rab se faryad. What is that? Halina ki rab se faryad. Then we have beta mange car scooter Baap Razi. Fine. So if I'll go with this part, so here when I'll make this periodic table, try to make this hydrogen, helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So if I'll go with the sequence order, please remember this is what? 1, 2, 3, and these are the atomic numbers. 1, 2, 3 and so on. When I'll come to this calcium part, this is actually 20. And we were asked what? Second group and 1, 2, 3, 4 and fourth period. This was the one. Again I am talking about the same question which we were asking. What was that? We are asked about the atomic number of the element placed in the second group and fourth period. Now what's that? We have actually remembered the trick, right? So here, first group, second group. In the second group, we are talking about fourth period. So this is what? This is actually calcium, right? So here, if I'll go with this part, this is the point. So this is calcium. Calcium's atomic number is 20. And we must remember the sequence order till 20. I guess this is clear. Madhna, is it clear? Udbhav and all the other candidates who are there in the session, kindly like it so that we can go in the detailed manner. Okay, so here we have calcium as the correct answer, that is 20. Fine. So I'll write also, it's actually calcium. Got my point? So this is actually asked in the examination in the similar manner, and this has been asked many times, not only CGL, CHSL exam as well. Okay, so they can directly ask this particular group, this particular period, so you'll directly relate it with that particular periodic table. Fine. Okay, let's move forward now. Next question is, Rn is the chemical symbol of which of the following elements? So this is from CPO 2017. What is the correct answer for this? Question is, Rn is chemical symbol for which element? Is it radium, radon, rhenium or ruthenium? What is the correct answer for this? Yes, answer please. And everyone who is there in the session, kindly like it and share it. And please let me know this answer so that I can go in the details. Otherwise, if you will not discuss, how would I go in detail? I'll just tell all the important facts, no doubt. But whatever doubts are there in your mind, I want that answer as well, right? So we have Madhna here, and Madhna is saying, sir, it would be radon. Simple one, true. So if someone asks you about the noble gases, we have helium, neon, argon, krypton, but what about those radioactive part? Fine. So yes, here radon is the correct answer, which is having the Rn as the chemical symbol. So yes, radon is the correct answer. Next, if I talk about radon, it is here. Fine. Next, what is the chemical symbol of iron? The most basic question, but just have a look where it is asked in CGL. Okay. So what is the chemical symbol for iron? No need to explain this part, right? We remember when we were talking about those Latin names. For example, if I'll go with the argentum, Ag, if I'll go with the aurum, Au, gold, silver, right? In the similar manner, if I'll talk about this iron, then remember ferrous part, ferrum part. Yeah, totally correct. It's obvious. We are talking about Fe. So no need to discuss about that, right? Moving forward. Yeah. So this is the periodic table. I'll explain other things. In a periodic table, while moving from left to right in a period, the number of dash remains same. Now, what is the answer? Then I'll explain this. This is from CPO 2017. What is the correct answer for this? What remains same in a periodic table when you're moving from left to right in a period? So what's period? Again, I'll say these rows 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So if I'll move from left to right, I'll write here also. When I'm moving from left to right, what is going to be same? So this I'll explain, but before that I want answer. So Madhana and others, can you give me this answer? Will number of electrons remain same, protons, shells or neutrons? What is going to remain same? Then we'll explain this part. So Madhana, you have given answer B for, okay, that was for the last question, right? So yes, everyone who is there in the session right now, I want this answer so that I can explain with the periodic table. I have periodic table here and I'll be explaining all those facts. But answer please. And everyone who is there in the session, kindly answer this. Yeah. So we are talking about the periodic table, right? So just have a look. When I'll move from left to right, what is going to happen? Here, the number of shells will remain same. Please remember, the number of shells will remain same, and if I'll move top to bottom, here number of shells actually increases. Number of shells increases. Now, what is that? What does it mean? Let's understand this. So, totally correct, Madhana. Your answer shell is absolutely correct. Now, let me explain this part. When I'm talking from top to bottom, let's say hydrogen. I have told you, just remember the sequence order for the atomic number. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. If I'll go with this part, that is in the sequence order, I know hydrogen is coming at the first number. This means hydrogen's atomic number is 1. Then hydrogen, helium, lithium. What? 3. So lithium is having atomic number 3. Then hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. In this manner, when I'll go with the sodium part, what is its atomic number? Its atomic number is 11. Now why I am writing this? Let's try to understand. What happens when I am writing this atomic number? From this atomic number I can create electronic configuration. What's that? Using that electronic configuration only, I can make the number of shells and I can tell how many electrons will be there in the valence shell. Now there's a formula, very important in the examination this is asked. There's a formula that is 2n square. Very, very important. It is asked in the examination many times. This is the formula using which we can tell how many electrons are going to come in the first shell, how many electrons will come in the second shell, how many electrons will come in the third shell. What are these shells? See, the innermost shell is represented by K, then second one L, then M, then N and so on. So if I'll try to write how many electrons can come in the K shell, what I'll do, I'll use the formula 2n square. This is at the position 1, right? So if I'll just put the number 1, so 2 into 1's square, it gives you what? 2. So here maximum 2 electrons can be filled. I'll use another color. Here maximum 2 electrons can be filled. If you have any sort of doubt, please let me know. Madhana, is it clear till now? And everyone who is there in the session, is it clear? Next, if I'll go with the K shell, just try to solve it. 2 into 2 square, just a second. 2 into 2 square, it is going to give you what? So it is going to give me 8. That is, I can fill 8 over here. Now let's try to use the same concept here. In the innermost shell, how many electrons can come? Sir, in the innermost shell only 1 electron can come because here only 1 is there. Now, if I'll go with this 3, so this means in the innermost shell 2 and then outermost shell maximum 8. But we have only 3 here. So what will be its configuration? It will be 2, 1. That means how many shells are going to be there? So if I'll talk about the number of shells, just have a look. 2 electrons inside and 1 electron here. So here, just have a look. Number of shells has increased. Here is only a single shell. Here we have 2 shells. That is, when I'm going from up to down, number of shells are increasing. But when I'm going from left to right, the number of shells will actually remain same. So please remember, the number of shell actually remains same when we are moving from left to right. So you are absolutely correct. Now moving forward with the next question. Which of the following atoms has the lowest ionization potential? This is from Chsl 2016. So Madhana, can you answer this? Which of the following atoms has the lowest ionization potential? What is going to be the correct answer? And everyone who is there in the session, kindly start commenting so that I can explain each and everything. Yeah, answer please. Which of the following atoms has the lowest ionization potential? And everyone who is there in the session, kindly give me your names so that I can start talking to you, and we'll go with the detail with each and every option and question as well. Yeah. Lowest ionization potential. First I want the answer, then I'll start explaining it. Answer please. We are talking about the ionization potential. Now what does it mean? Ionization potential means, if I talk about the number of shells, how easily I can take out electron from there. What I'm saying, again I'll repeat my words. How much potential is actually required in removing that electron? Now it's very simple. Try to understand this. Madhana is saying, sir, is it A, that is nitrogen? Madhana, I'll explain this. Just have a look. Just try to understand this part. If I'll make a shell, here we have nucleus with the positive charge, and here we have electrons. Now try to understand. Here we have positive charge, here we have negative charge. That is, they are going to attract each other. Now, if this electron is present near to this nucleus, this means it will be having more attractive power towards this electron, right? But if the number of shells will increase, the distance between this positive charge and this electron, that is the negative charge, is also going to increase. Now, if this distance will increase, this means nuclear charge will, this nucleus is not going to attract this electron with the same tendency it was attracting this electron. Is it right? So please try to understand. Again, I'll use the same concept. Here we have nuclear charge. We have nucleus, that is the positive charge in this electron. Small distance, that is its attraction power is more. But if I'll go with this charge, just try to understand, this is the outermost electron. Now what is happening? The distance has increased. Now we can talk about the long distance relationships, right? So we are, as a boyfriend girlfriend, if they are in the college time, they are near to each other. If someone comes and says, hey, can you be my girlfriend? She'll directly say, no, I have a boyfriend, right? But what if we are talking about the larger distance? Electron can be taken out easily. The same concept is applicable here, and Madhana is given the answer O. So let's try to understand with these options. See, when I'll go with the first group, we have Halina ki rab se faryad. That is Halina ki rab se faryad. Now we have here, from here, right? Then we have oxygen. What's left? Nitrogen, that's left. So let's try to understand. We know that if we are going from left to right, when we are going from left to right, here they are actually requiring the electrons, they are actually present, which are actually non-metals. But if I'll go downwards, I know that number of shells are going to increase as I'm going downwards, right? Now if I'm going downwards, number of shells are increasing. So this electron's distance with this nucleus is also increasing. If I'll try to compare them, so here we have nitrogen, here we have oxygen, nitrogen is there, oxygen is there. Then if I'll talk about cesium, is actually here and it is here. Now just try to have a look from top to bottom, which is at the bottommost part, that is cesium, right? So what you can do, you can directly relate with these options and directly say, sir, what is going to be the correct answer? The correct answer is going to be cesium. Why? Because we know that if we are talking about the electron losing tendency, so easily electron can be taken out from the periodic table if it is at the bottommost part. Got my point? So here cesium is going to be the correct answer. Just try to have a look over here. Cesium is present here. It is in the 6th group. That is, the number of shells are going to be maximum here in comparison to your nitrogen, oxygen and arsenic. Got my point? So if it is clear, please remember this point. Number of shells will increase if you are going top to bottom, and easily electron can be taken out from this part. So that's why option number C, option whichever was it, cesium is going to be the correct answer. Okay, let's move forward now. Ionization potential for the inert gas is dash. So we have understood this fact. Now I want the correct answer, Madhana. And everyone who is there in the session, kindly give me this answer. And yes, I have many tricks. I have tricks for each and every question. Just try to answer this and start conversation with me. So yes, everyone is requested to kindly give me your name so that I can start talking to you. And please answer this part. Yes, ionization potential for the inert gas would be 0, low, high or negative. What's ionization potential? I have told you. How easily electrons can be taken out. That is how much potential you are going to apply for taking out those electrons in the easy language. So for the inert gas, just try to understand what's that specific thing which we must know about inert gas. Inert gas has their outermost shell with the complete octet or duet. This means their outermost shell are complete. They don't want to do any sort of reaction because they are already complete. What if I'll talk about the first group, second group and all? They are doing what? They are actually having excess of electron, they are donating so that they can have their octet complete or duet complete. Now you must be wondering, sir, what octet, duet, what is that? Let's try to understand this. If I'll go with the first group, Halina ki rab se faryad. So sodium is having atomic number 11. So its electronic configuration is 281. Remember the formula? 2n square. Now for any element to be stable, everyone wants to be stable. Even you, I, we all want to be stable in our life. We must have a good family, we must have a good amount of money so that we can have a happy life, right? In the similar manner, for the happy life, they actually want their outermost shell to be filled. Now, for hydrogen, helium and all, we can talk about 2 of the electrons in the outermost shell, and others we will talk about, for example, sodium and all, 8 electrons in the outermost shell. Now, just have a look. It is having 1 electron in the outermost shell. This is the issue for them. So, what he can do, they can either take 7 electrons or can give 1 electron. So, what's easier? It's easier to give 1 electron, right? So, this sodium can give 1 electron, and if I'll talk about chlorine, its atomic number is 17. That is configuration 287. So, here again it is unstable. So, it requires 1 of the electrons. So, what they'll do, they'll say, okay, I am giving you 1. So, it will be having 28 as the electronic configuration and it will be having 288. Both are stable now. So, yes, if I talk about this inert gases, that is why I'm talking about the noble gases. In the inert gas, we can talk about xenon, okay, the stranger gas. So, here, noble gases are actually already having their octet complete, right? So, do you think what would be the ionization potential? It will be very high. We cannot take out electron from them. So, yes, here, Madhana, it would be high because we are already having outermost shell already complete. 1, 2, 3, 4, 5, 6, 7, 8. So they will not give any electron. See, here sodium was giving electron. Why? Because it wanted its outermost shell to be completed with 8 electrons. That's why it has given 1. Chlorine, it wanted 1 so that it can again become 8. But since they are already 8, why will they give? Why will they give their electron? They are already complete there. That's why they will be having highest ionization potential. Did you receive this point? So we have Chinmay Das and they have given the answer, so it would be D. Please remember, it is going to have the high ionization potential. Got my point? So if this is clear, we can move forward now. So if I'll talk about this 18th group, fine. This is actually noble gases and their outermost shells are already complete. So they don't want to react with anyone and hence they will be having the highest ionization potential. Fine? Yeah. It is one and the same thing. If I'll write I potential, see, if I'll talk about the ionization energy, so it's the energy which is actually required to pull the electrons. So if I'll talk about the energy that is required to pull the electrons, so it would be lesser if I am at the bottommost part of the periodic table. Got my point? So yes, if I'll talk about directly about the energy, so it's the amount of energy which is required to remove the electron. So you can now relate with all the concepts which we have discussed right now. Fine? Okay. So Madhana, Chinmoy, I guess these points are clear. Next, the correct order of electronegativity of FNOP. Can you tell me about this? What is going to be the correct answer for this part? Yeah, answer please. Answer please. Nitrogen, oxygen, fluorine, right? Just try to relate it with this part. If I'll draw the periodic table, this would be the sequence order. So this is going to be your 15, 16, 17. O, say, tipo, and then possible, yeah. So I'll just mark red color and from this it would be easier. So we are talking about nitrogen here, oxygen we have here, then okay, we have phosphorus here. Yeah. So these are the 4 points. So yes, try to relate it with this. Now what is electronegativity? If I talk about the electronegativity part, please remember, when I'm moving from left to right, here the electronegativity actually increases. It's the tendency of taking the electrons. That is, we are talking about non-metallic character over here. What is non-metallic character? Non-metals are the one which actually gains the electrons in order to complete their octet, or we can say that they are actually into the bonding part and all. But if I talk about the electronegativity, so from left to right it actually increases. So just try to relate with these options. I have made it simple for you. So Madhana is with B, that is FOP then N. Okay, FOP and then N. Okay, then Chinmay, can you answer this part? And everyone who's there in the session now, please answer this, because after answering this, all your logics will be cleared up. Yeah, electronegativity. So I have already told you, when I'm moving from left to right, electronegativity is going to increase. But if I'll move from top to bottom, it will actually decrease. So yes, answer please. From top to bottom, it is going to decrease. It would be easier to understand. Yeah. So see, Madhana, you are saying that answer would be B. That is FOPN. Now just have a look. FOPN. So what I'll say, when I'm talking about electronegativity, so for the decreasing order, we know that from top to bottom it is going to decrease, right? But here, first of all, let's have a look. It is increasing in this manner. It is, so F would be at highest, then O, then N, and then P. So what's that? F, then O, then N, then P. Yeah, so option number C would be correct over here. Got my point? So please remember, electronegativity is increasing from left to right of the periodic table. So option number C would be correct here. Just have a look. When I'm moving from left to right, so this would be highest, lesser, more lesser, more lesser. So F, O, N, P. So here this is the sequence order, and hence option number C would be correct. So Madhana, Chinmay, if anyone has doubt over here, please let me know. Is it clear? Is it clear, so that I can move forward now? So this was the logic for the electronegativity. And electropositivity is totally opposite of electronegativity. Totally opposite. It is increasing from left to right. Correct? If I'll talk about electropositivity, it will decrease from left to right. It is totally opposite. Totally opposite. Okay. So this is also clear. Okay. Let's move forward now. Then we have, what is the unit for physical quantity radioactivity? What is the unit of the physical quantity radioactivity? Is it radian, becquerel, steradian, or Kelvin? Basic question. This can be answered in the first go. Okay, cool. Answer please. What is the unit of physical quantity radioactivity? Okay, Chinmay. Fine. Very basic question. Radioactivity. I guess I'm getting your comments quite late, huh? Madhana, totally correct. It's very obvious. Chinmay, I guess you are also with option B. It's totally correct. The correct answer is becquerel. And the thing is that when we talk about this radioactivity, radioactivity was actually discovered by Henry Becquerel, and on his name itself, this particular unit is given. Please remember, apart from this Becquerel, we have Curie as the unit. But this Becquerel is also the SI unit. This is asked in the examination, so we must remember. If I talk about SI unit, it is Becquerel. But if I talk about other units also, then Curie is also going to be the correct answer. Fine. So yes, Henry Becquerel was the one who has discovered this radioactivity. Next, in India, nuclear weapon was tested at which location? This is from CPO 2007 and CHSL 2011. Now you must have watched the movie Parmanu, right? So it was during the time of Atal Bihari Vajpayee ji, and if I'll talk about APJ Abdul Kalam sir, at their time this was actually done. So yes, this testing. So where was it done? Is it done at Sriharikota? Is it Bangalore, Pokhran, or Kanchipuram? What is the correct answer? Okay, Udbhav. So Madhana is with C, said Pokhran. That's true. If I talk about these nuclear weapons testing, it was actually done at Pokhran. Okay. Totally correct, Udbhav. Absolutely correct. Okay. Let's move forward with this question. Device which is used for the detection and measurement of all the types of radiation, whether it is alpha, beta, gamma. This is from CHSL 2016. What is going to be the correct answer? Chinmay, great, awesome. What about this question? Device used for the detection and measurement of all the types of radiation. So I'll talk about, yeah, Udbhav, absolutely correct. Awesome. So what I was talking about, I was talking about this measurement of the radiations. Please remember, when we talk about these radioactive elements, where you can talk about the uranium, you can talk about plutonium, what happens? They have unstable nucleus. Because of the instability of this particular element, what happens? They keep on emitting alpha ray, beta ray, and gamma ray. That is alpha radiation, beta radiation, gamma radiation is there. Now, if I want to measure these radiations, so for measuring this radiation, what can be used? So, Madhana, you are absolutely correct. That is, it would be Geiger counter. Or if I'll talk about the full name, it would be Geiger Mueller counter. So, yes, first option, that is Geiger counter, is the correct answer. That is option number A. Udbhav, absolutely correct. And Chenmay, please remember option number A, that is Geiger counter would be the correct answer for measuring this type of all the types of radiations. Next, which one of the following is not a radioactive element? Now, this is the question. This is from CPO 2005. Is it uranium, thorium, plutonium, or zirconium? This is slightly confusing, but need this answer. What is going to be the correct answer for this? Correct answer, please. Yeah, answer please. So we have four options: uranium, thorium, plutonium, zirconium. What is going to be the correct answer for this part? Madhana is with D. Okay. Others, Udbhav, Chenmay, others, all the other candidates. And yes, who all are there in the session, kindly like it and share it so that we can have more candidates and we can discuss about each and everything in the detail. See, if I talk about these radioactive elements, we know that uranium is used in the nuclear reactors, right? In the similar manner, if I'll talk about thorium, plutonium, these are radioactive elements, and we can directly detect about from their atomic numbers as well. But if I'll talk about zirconium, zirconium is not a radioactive element, and Madhana, you are absolutely correct. Option D would be correct answer. So if I'll talk about uranium, thorium, and plutonium, these all are radioactive elements. And what are radioactive elements? We have understood. These are the elements from which, because of their instability, alpha, beta, delta radiations are always there. Chenmay, every day our class starts from 12 to 1. And from 12 to 1, we discuss all the previously asked questions in the different SSC examinations. It can be SSC CPO, it can be CHSL. And in the evening, between 6 to 7, we have previous year questions of CGL examination, just CGL along with the theory part. Okay, so let's come back to this part. So yes, zirconium is going to be the correct answer. Next, radioactive noble gas is dash. Now, this is from SSC Steno 2014. Is it xenon, helium, neon, or radon? What is going to be the correct answer? And this is very important because in the examination, it creates confusion. And it is asked many times. So yes, radioactive noble gas is dash. So what is going to be the correct answer? Madhana, can you answer this? Chinmay? Xenon, helium, neon, or radon? So Madhana is with D. And Chinmay, are you also with the same answer? Udbhav? So yes, you all are correct. Please remember, if I'm talking about radon, so radon is actually a radioactive noble gas. I'll write full form as well so that you don't get confused. So yes, radon is actually a radioactive noble gas. Absolutely correct. Absolutely correct. Udbhav, Madhana, Chinmay. Okay. So we have next question now. There is no change in radioactive element, mass or charge during which kind of emission? Is it gamma emission, oxidation, alpha emission, or beta emission? What is going to be the correct answer? Chinmay, you are absolutely correct there. I got your comment quite late, but yes, answer for this, radioactive noble gases is dash. Answer please. Answer please. So we have Jagdishan here, and Jagdishan is with oxidation. Okay. Chinmay, Madhana is with B, that is oxidation. Udbhav is also with B, oxidation. And Chinmay, you are left. Are you also with the oxidation part? See, when I talk about alpha, beta, gamma, here please remember what happens when we talk about the atomic number and mass number, there is some change. But Only and only when we are talking about, when we are talking about this gamma part, there is no such change. So in the gamma emission, there is no such change in their atomic number or the mass numbers or in the charge. I'll explain this part. What happens in the numericals, it is sometime asked, if we are talking about any, let's say any element X, it is having some atomic number and mass number. Now what happens if gamma ray is actually passed through it? So what will be the change in its atomic number or mass number? So there is no such change over there. Now, apart from this question, one more question is asked. What is the question? When we talk about this alpha, beta and gamma, so if I talk about the penetration power, alpha, beta and gamma. So please remember, the penetration power of the gamma ray is maximum. Then we have beta ray and then we have X-ray. So this penetration sequence order is also very important. Please remember, penetration is maximum for this gamma, then for beta and then for alpha. It is asked in the examination, so I am writing here. It is actually penetration power. If you are from Hindi medium, we call it Bhedan Shakti. Penetration power is maximum for what? So it is maximum for gamma. Please remember this part. Fine. Okay, let's move forward now. So here gamma was the correct answer. Next, radioactive samples are stored in lead boxes. Lead boxes are actually used because of what? Because they are heavy, they are strong, they are good absorber, or they are bad conductor. What is the correct reason for this? If I talk about any of the radioactive samples, you know, radioactive elements, we are talking about uranium, thorium, plutonium. In the similar manner, if I talk about any of the sample, radioactive sample, so it is actually stored in lead boxes. There must be some reason behind it. So what's the reason behind it? Lead is heavy, lead is strong. Is it good absorber or is it bad conductor? What is the reason behind it? This is from Chsl 2009. What is the question? Question is asked, if we are talking about any of the sample, radioactive sample, it is stored in this lead box. There might be some reason behind it. Now what's that? If I talk about these emissions, we know that the radioactive elements will do what? They'll emit what? Alpha, beta, gamma. Totally correct, Jagdishwan. Totally correct. So we have Jagdishwan's answer here. That is, lead would be a good absorber, and that's true. So it will be preventing. R is saying D. No R. It would be actually good absorber. Fine. So Madhana, Jagdishwan, C is the correct answer, and R. Please remember this, because lead is the good absorber. That's why we are using lead over there. Okay. Let's have next question now. Nuclear forces are dash. Now this is from MTS. But this one is important. It's not only from the MTS, it is also asked in the CGL and CHSL examination also. So all the examinations are covered with this question actually. So yes, nuclear forces are charge independent, spin independent, charge symmetric or long ranged. What is going to be the correct answer? So we have Udbhav, yes, your answer was correct for the previous question. Totally correct. But this one, nuclear forces are what? So till the time you are giving me the answer, I'll explain the part. When you are in the physics section, when you are discussing physics, yeah, that's true, Chinmay, correct. So yes, what I was saying, when I was talking about these forces in the physics section, we were discussing fundamental forces, remember? When I was talking about fundamental forces, in those fundamental forces, there was a question which was asked in the examination as well. One of the force was gravitational force, remember? One of the force was gravitational force and another force was nuclear force. Gravitational force and nuclear force. Now if someone asks me, so which is the strongest force? So please remember, nuclear force is the strongest among all. Strongest force. And which one was the weakest force? So here, if I talk about gravitational force, it was the weakest force. But one more thing that I explained at that time was, nuclear force is the strongest force. No doubt about that. But it is actually short ranged. It is actually short ranged, right? But here in the option, it is what given? It is long range. So it is totally correct, right? So if I talk about this charge independent, the answer is given by whom? Jagdishwan, you are absolutely correct. Let me tell you, if I talk about this charge, if I talk about this protons, we know that positively charged. So whether it is proton, whether it is neutron, or whether it is proton, they all are going to have the same intensity. Fine. So please remember, all these will be same, and that's why they are actually not dependent on the charge, and hence we can say that they are actually charge independent. So again I am saying, if I talk about fundamental forces, gravitational force is the weakest one, nuclear force is the strongest one, but the nuclear force is actually short ranged. And please remember, these nuclear forces are charge independent. There is no such effect of the charge. So we will talk about proton, positive, neutron. So please remember, that is not dependent on that. So yes, option number A is going to be the correct answer. Next. So before moving forward, let me tell you there's an example official application which is one-stop solution for all the government job aspirants. We are going to have live paid courses. Then we have free subject-wise and topic-wise quizzes with the report card. Then we have job alert, admit card, examination date, all exam previous year PDFs with the solution. Then we have topic-wise free live classes, free exam-wise PDFs and practice set PDF, daily, weekly, monthly current affair, all these at a single platform. Just go to this particular Play Store, type Exampur there, click on the install button, click on the open part, just do the registration and start using it. So we have next question. The question is, radioactive elements emit what? It's very basic question, but answer please, and then we'll revise the chemistry part because there are many things which I want to explain there. But I want this answer first. Radioactive element emits what? Now this is from Chsl 2016. What does it emit? Yeah. See, if I'll discuss about that now, it is going to create the confusion. So what I'll do, we are going to have the discussion on this part. One by one, we'll be covering with all those particular topics. So I'll just explain tomorrow when we'll be having discussion on this part in a detailed manner. Fine, don't worry about that. So yes, radioactive elements emit what? Very basic question right now. So Madna, R, you all are with D. Totally correct. That is alpha, beta and gamma radiations. Okay. Next question is, the element which is commonly used in nuclear reactor for producing electricity in the nuclear fission is what? Now this is from SSC section officer audit 2001. Is it radium, plutonium, uranium or deuterium? So I have to go in the details, so need answer in the super fast manner. Jagdishan, totally correct, totally correct. And yes, we have to discuss electronic configuration in the detailed manner, so don't worry about that. We will be discussing all those particular parts where we have to discuss what? How we are actually filling those shells, what are valence electrons, what is the valency. So we'll discuss about that. Yeah. So the question is the element, and Jagdishan is with uranium, Chinmay is also with D, that is deuterium. Jagdishan is with uranium, that is C. Chinmay is with D, Madhana is with C. Okay. See, the element which is commonly used in the nuclear reactor for producing electricity, this is actually option number C, that is uranium. So Jagdishan, Madhana, you're totally correct. Chinmay, please remember, you're talking about option number D. See, if I'll talk about this deuterium part, I'll just explain heavy water. There's one more question which is going to come in the next part. So we have to wait for 5 minutes for that. Before that, let me explain. Uranium is the one which we are using in this nuclear fission process. Now, for this nuclear fission process, we know that we are talking about nuclear reactors, right? So in the nuclear reactor, which particular this process is going on, we know that that is nuclear fission. So I'm writing for you all, nuclear fission. This is taking place in nuclear reactors, right? Nuclear reactors where we are using uranium, for the production of electricity or power generation. But if I talk about fusion, can you give any 2 examples for this nuclear fusion process? Everyone, for nuclear fusion, can you give me 2 examples where those nuclear fusion is taking place? Is it atom bomb? Yeah, that's true. Protium, deuterium, tritium, right? So if I talk about deuterium, it is the isotope of hydrogen, where I'll explain heavy water in coming 2 minutes. But answer please. I'm talking about fusion. Where is it taking place? Any 2 examples? No. Deuterium is not heavy water. No. Deuterium is not heavy water. That is different thing. I'll be explaining 1 more minute, but before that, answer, please. Jagdishan, please do not go with deuterium and heavy water. It's not one and the same thing. It's different. I'll explain. Yeah. So if I talk about fusion, one is hydrogen bomb, and second one is sun and hydrogen bomb, where you can talk about Yeah, you can talk about any of the star which includes sun, right? So yes, now moving forward. So there was a question that was asked, but before that, nuclear power reactor acts on the principle of what? So fission, fusion, thermal heating, combined effect of all the three given above. So this is from SSC text in 2008. What is the correct answer here? No issues, no issues. I'll just explain that part. Just after this question, we are having the same question which you are asking for. But answer this. Nuclear power reactor acts on the principle of what? So we have understood what when we are talking about the nuclear power reactor, we are talking about uranium, which is actually used there, right? Radioactive element, and the process which is going on is what? So no need to ask from you all. You all know the answer, that is fission. Totally correct. That is option number A. Now here comes the question: who invented this nuclear reactor? So who was he? Totally correct, Madhana. Jagdishan, totally correct. Now if I talk about the nuclear reactor, who has actually invented it? So there might be someone who has actually invented it. So who is he? I gave you the trick, right? In Hindi medium, if I talk about heat, we call it garmi. And from this nuclear reactors, what we are doing? We are generating the power. So Fermi se milegi garmi. It's something like that. That Fermi has invented something from where we are getting garmi. So which is actually preventing us from garmi. We are able to run these ACs and fans. So totally correct. Chinmay, Jagdishan, Madhana, R, you all are correct. The correct answer is Enrico Fermi. Now comes the question that two elements which are used to absorb the neutrons in nuclear fission during the chain reaction is what? This is asked in CGL 2011 and SSD CPO 2010. What is the correct answer? Arey wah Chinmay. Awesome. Great. So remembering the year as well. But in the examination, they have actually stopped asking for the years. But it's good that you have remembered it. If you remember, that's nice. But yeah, two elements which are used to absorb the neutrons in the nuclear fission during chain reaction. See what happens when we're talking about this neutrons. So there's a bombardment of the neutrons and they have very high energy. We need to control that energy, right? So we need to absorb those neutrons. So Madhana is saying that it would be boron and cadmium. Cadmium boron is used as a control rods. Totally correct. If I talk about the control rods, so here we have boron and cadmium. So here you all are given the correct answer, that is boron and cadmium. That is option number A is going to be the correct answer. Next, graphite is used as a dash in nuclear reactors. What is the use of this graphite? Graphite is used as what? Is it fuel, lubricant, moderator, or electric insulator? Now this is from CGL and CHSL, both CGL 2008 and CHSL 2012. And then we are going to discuss on the heavy water. But answer this. All these questions are repeatedly asked. Don't go only with these years. These are only the years which I have actually written on the board. Apart from that, it is asked many times in different examinations. So yes, graphite is used as what? Totally correct. Jagdishan, you are absolutely correct. The correct answer is going to be moderator. Now, we were discussing about one thing, that is heavy water. Now, heavy water is used as a coolant in nuclear reactor because of what reason? So, you can give me the reason and then I'll explain what is this heavy water. So, Udbhav, great. Correct answer. So, this is the last question of the day. And then we'll be just summarizing what all we have discussed today. But answer please. Heavy water which is used as a coolant in the nuclear reactor. What is heavy water? So is it water rich in minerals? Is it ozonized water? Is it water containing minerals of heavy metals? Or is it water containing heavy isotopes of hydrogen atom? What is the correct option? Is it ozonized water? If I talk about ozonized water, we remember about ozone, right? What's ozone? Ozone is O3. We all know that. But answer please. So Jagdishan is with C. That is it is containing water which is containing the minerals of heavy metals. Okay. Madhana, Chinmay, R, need answer from everyone. We need to understand something here. Many of you will be giving deuterium over there. Remember? Madhana is again with C. That is water containing minerals of heavy metals. Okay. R, your answer please. You're pending. Chinmay, your answer is also pending. Please give me answer fast so that I can start explaining this. See, when I talk about this heavy water, this is not just a D. Jagdishan, you're asking me now. Sir, is it deuterium? It's not only deuterium. If it would be deuterium, its formula would be D. It's what? If I'll talk about heavy water, it is D2O. In the similar manner, if I'll talk about normal water which we drink, what's that? That is H2O, right? But here if I'll talk about heavy water, that is D2O. Do not forget. So what is this? We know that it is deuterium, and deuterium is what? It is an isotope of isotope of hydrogen. So please remember, it is a water that contains heavy isotopes of hydrogen atom. Now if I'll talk about the isotopes of hydrogen atom, what are they? Isotopes of hydrogen are protium, deuterium and tritium. Remember? So this, from here, this D is derived and D is giving you D2O, that is what it would be? D2O, which is actually known as heavy water, and heavy water is used where? These are actually used in nuclear reactors. I guess all these points are clear. So now just summarizing what we have discussed today, we started with the chemistry part in which we have studied about the periodic table. Don't worry, in the next week we are just putting 3 classes with only the theoretical section, in which we will be starting with the periodic table, then we will be having chemical bonding, just theory, no questions we have discussed today itself. So we'll talk about periodic table. We remember, who was he? He was Moseley, who has actually given the present periodic table which we are using right now. This idea originated in whose mind? He was Mendeleev, where we were discussing about atomic masses, but the modern periodic table actually uses the concept of atomic numbers. How many rows are there? There are total 7 rows, in which those 7 rows are actually known as what? Okay, thank you for that. Yeah, so 7 rows are what? 7 rows are actually known as periods. Fine. What about those 18 vertical columns? Those 18 columns are known as groups, where if I talk about the 18th column, that is actually known as noble gases. From where we know that they are not going to do any kind of reaction, they are not participating in any kind of bonding. Why? Because their outermost shell is already complete. But why this first one, that is first group, in which we can talk about sodium? Why this 17th group, where we are talking about chlorine? This sodium and chlorine are actually combining and forming that NaCl that we eat every day. Why it is formed? We will be discussing this same question tomorrow, because tomorrow I will be discussing chemical bonding. Okay, so yes, let's meet tomorrow, where we are going to discuss chemical bonding, and please mark my words, you will be enjoying the session. But only request is, please come on the time so that I can start giving all those examples by interacting with you all. It's good that I have met with such a wonderful audience, but you were quite late. Otherwise, I would have given more examples in depth today itself. There were many examples of girlfriends and boyfriends which were actually easier for you all to understand those electronegativity, electropositivity concept. But no worries, we'll meet tomorrow with all those particular wonderful examples. But the request is, just come on time. Fine. Okay, so I'll be meeting for you all tomorrow between 12 to 1 with the concept of chemical bonding, and don't worry, we have awesome examples, but I want you on time. Okay, so bye bye everyone, take care, and thank you for being such a wonderful audience. Bye bye.